Good morning, everyone. Welcome to the second part of video on data analysis. So as you know, in my previous video, we discussed about what is data analysis, then what do you mean by different types of errors, uncertainty, how do you use graphs, right? And then we have seen about different types of graphs, what kind of problems can be solved using different types of graphs. Seen all this. Now, let us start with one more. Just a moment, let me put on my mic. Right. Okay, so now what we'll do is let us understand about uncertainty calculations, which is extremely important from your calculation point of view. And at many places in your IB papers, paper 1, we use this uncertainty calculations. Okay, let me share my screen. Right. So this one also I would be able to do it only for maybe 15 minutes or 20 minutes, and then I will take a break and let us continue once again after this. Okay, so let me share this slide. Put over here, right. So handling uncertainties. So if y is equal to, this is the formula is already there in your data booklet. Now what we do is, let me consider some examples. Let us say, if I give you some value like y is equal to 2 centimeter plus or minus 0.2 centimeter, 0.2 centimeter. This is your length of a line. What does this tell you? It tells you the error that is permissible. Okay, so when I say delta y, now what is this actually here? This can be written as y0 plus or minus delta y. What is delta y? This delta y is called as absolute uncertainty. This is called as an absolute uncertainty. Okay. Absolute uncertainty. Now, what is the unit of delta y? Delta y unit is also centimeters. Remember, absolute uncertainty will always have a unit. Okay. Next is, let us say, for example, I have a rectangle and I want to find out what is the value of the absolute uncertainty in the rectangle. And I say the length of this rectangle is seen to be 5 centimeter plus or minus 0.2 centimeter here. And here it is 3 centimeter plus or minus 0.1 centimeter. Now I'm asking you to find out the absolute uncertainty. So how do we do this? So we do it like this. So absolute uncertainty, total absolute uncertainty in finding out the perimeter. Now what is the perimeter here? Perimeter is equal to how much is it? It is 5 plus 3, 8, another 5, 8 plus 5, 13, 13 plus 3 should be 16. This should be 16 centimeter plus or minus as uncertainty. So here you have plus 0.2, here it is 0.1. 0.2 plus 0.1, 0.3. Similarly, 0.2 plus 0.1, 0.3. 0.3 plus 0.3 should be 0.6. 0.6 centimeters. Thus, the absolute uncertainty in measuring the perimeter is seen to be 0.6 centimeters. I hope this is clear. Okay, now let us move on to the next part. It could be for any geometrical figure, any object that we have. This is the way how you need to calculate the absolute uncertainty. Absolute uncertainty will always be added up. Let me take up one more. Let us say, for example, here you took the perimeter here. Now I define a quantity given by, let us say, z is equal to something like a minus b, where a and b are the lengths of each side. So this is the length a, this is the b over here. And I'm asking you to find out the value of z and as well as the value of delta z. So how do we do it? The value of z is straightforward. So what is it now? What is A? A is nothing but 5 centimeter. B is nothing but 3 centimeter. So answer should be 5 minus 3, which should be equal to 2 centimeter. See, I have not asked the perimeter here. You need not add, subtract everything. I just asked A minus B. Okay, so this is nothing but 2 centimeter. And then even I look at delta Z over here. What is delta Z? Delta Z here is plus 0.2 and here it is plus 0.1. So therefore, you are going to add them. Okay, you're not going to subtract them over here because you have a negative sign over here. You're not going to subtract them, but instead you are going to add and say 0.2 plus 0.1 is equal to 0.3 centimeter. This should be your value of delta Z. Let us take up one more example. Let us say Z is equal to something like 4a minus 2b. Okay, now what will happen for delta Z? Now first let us find out 4a minus 2b. What is 4a into a? 4 into A. What is value of A? A is here. This is A here. 4 into A is nothing but 20. 20 minus 2B. 2 into 3 should be 6. So therefore, this should be equal to 14. 14 centimeters should be equal to 4A minus 2B. And what do I need? I need the value of delta Z. Delta Z should now be equal to, what is the value of delta Z in this? See, what do you mean by 4A? 4A is nothing but A plus A plus A plus A. Okay, don't take only one value, which means what? It should be A is nothing but 0 0.2, 0 0.2 plus 0 0.2 plus 0 0.2 plus 0 0.2, which should be 0 0.8 here, 0 0.8 here, plus, now what is the value of 2B here? You multiply this by 2, which should be 0 0.2 over here, 0 0.2, the answer should be 1 centimeter here, right? Thus, the value of Z can be written as 14 plus or minus 1 centimeter, right? This is the way how you need to write down the uncertainty for the absolute uncertainty for these kind of expressions. I hope it is clear. If not, do ask me. I can show you some more worksheets, some more examples to get it more than this. Okay. Now let me move on to the next one, next slide, because we have three more uncertainties. One is nothing but your absolute uncertainty. The next one is relative uncertainty. The third one is fractional uncertainty. Okay. So far what we have seen is only about the absolute uncertainty. Right. Next, fractional uncertainty. We also call this as relative uncertainty. Relative uncertainty. Now, how do you calculate it? What is it? This is what you need to know here. Now, fractional uncertainty is nothing but, see, let me take up the previous example. The previous example tells you A is equal to 5 plus or minus 0.2 centimeter. That is what you got here, right? So therefore, the fractional uncertainty here is nothing but delta A divided by A. What is delta A here? 0.2. Don't take plus or minus. Just take 0.2. And value of A is nothing but this value, which is 5. Okay. So therefore, so this should now be equal to how much? 0.2 would be 2 by 10. 2 by 10 divided by 5, which should be equal to 1. 2 ones are 2 5s are, which should be equal to 1 by 25. This is your relative uncertainty. You can convert this into fractions, or you can keep it in fractions, or you can convert it into decimals. And if you want, okay, let us say, for example, in one of the problems, if I say the relative uncertainty for a variable is given by delta A by A is already given to be 0.4, and value of A is seen to be around 2 plus or minus 0.1. Okay, so, sorry, not 0.1, this is not given. The value of A is equal to 2 centimeter. Then find delta A. Then find delta A. How do I do? I can now write delta A is equal to 0.4 times A, which is 0.4 times, what's the value of A? 2 centimeter. So you can multiply this, you can get the answer as 0.8 centimeter. Thus, you can get from relative uncertainty to absolute error or absolute uncertainty. Remember, when relative uncertainty is given, you cannot write down the absolute error immediately, but instead you need to achieve a process like this to get this absolute error, absolute uncertainty. Okay. Now let us move on to the next one, which is fractional uncertainty. So not fractional, sorry, the percentage uncertainty. Percentage uncertainty. What is percentage uncertainty? So this is a very easy thing. Percentage uncertainty is nothing but relative uncertainty multiplied by 100. Whatever you did earlier, you just multiply that by 100, you get fractional uncertainty, which means you will be having, let us say, delta A by A is relative uncertainty. Multiply this by 100, this will give you the fractional uncertainty, but this will be represented in terms of percentages. That's what it was, fractional uncertainty. So towards it, now let us say, for example, in the previous case, your relative uncertainty was seen to be how much? Delta A by A here. Delta A by A is seen to be 125. So therefore, your percentage uncertainty will now be equal to, percentage uncertainty will be equal to 1 by 25 multiplied by 100. So 25 ones are, 25 fours are, which should be equal to 4%. Is this clear? Okay. So this is how you can calculate the percentage uncertainty. Okay, so far we have seen about what do you mean by relative uncertainty, percentage uncertainty, absolute uncertainty, and so on. But there's still something more that we need to learn over here. What is that over here? You need to know more about what are the mathematical simplifications that you need to do it. Okay, so towards it, I need to put 2 more slides. Right, let me try doing that also. Right, the first one. Now there are some equations that you need to know. The first equation is, it's given here. Y equal to a plus or minus b, delta y equal to delta a plus delta b, which you already know. We have seen this. If, for example, if I take a is equal to a 2 plus or minus 0.1, b is equal to a 3 plus or minus 0.5, then delta a plus delta b, what do? You take the 0.1, delta b 0.5, you add them, you get the total uncertainty. This we have done it. Now let us look at this one here, the product of it. If I have a value y is equal to ab by c, then delta y by y is equal to delta a by a plus delta b by b plus delta d by c by c. Okay, this is what we have. Now let me take an example to prove what is this, or to suggest what is this. Now we have a is equal to, let us say, 2 plus or, okay, we already have a equal to so much, b equal to so much. Let me define one more variable. C is equal to something like 5 plus or minus 0.1. Okay, I have put 3 different values, 3 different variables, and 3 different values over here. I want to find delta y by y. Delta y by y would now be equal to, it's given by this formula. What is this now? This value should be delta a. What is delta a? 0.1. What is a here? 2 plus delta b 0.5 divided by b here 3 plus delta c by c. What is delta c here? 0.1. What is c? 5 over here. Okay, let us calculate all this value. It should be 0.1 divided by 2 would be 0.05 plus 0.5 divided by 3. How much will this be? This should be 3 16s or 48. So this should be 0.016, right? 3 ones are, no, not 0.16, 0.16 plus this is 0.1 divided by 5, 0.033, right? When I add all of them, what do I get here? I get this is 0 here, 3 plus 6, sorry, this is 0.3. Okay, I'll take this 0.3, 0.16, 0.05, only 2 decimal places. So 3 plus 6, 8, 9, 9 plus 5 is 14, 1, 1 plus 1, 2, here there's nothing, and this is 0.24. What is this now? Delta y by delta y. What is this now? Relative uncertainty. If I want percentage uncertainty, what will I do? I'll write delta y by y multiplied by 100 will give me the percentage uncertainty, which is 0.25 multiplied by 100, which is equal to 24%. What we have got? We have got only the percentage uncertainty. But I want the absolute uncertainty. How do I get absolute uncertainty? I'll write delta y is equal to 0.25 from here. From here, 0.25 times y, which is equal to 0.25 into, what's the value of y? We have never found out the value of y. So how do I find here, right? Here y is equal to ab by c. What is a here? A here is 2. What is b here? 6. So a into b should be 6 divided by c is 5. The answer should be 6 by 5. So this should be 6 by 5. I'm taking this value of y and substituting it over here. How much will this be? 0.24 into 6 divided by 5. Let me use my calculator. So I have 0.24 star 6 divided by 5 will be equal to 0.288. Thus, right? Thus you can write this as 0.29 over here. Thus the value of y can be written as, how do you write the value of y? What is y? Y is 6 by 5. 6 by 5. What is 6 by 5? Let me write down that also. 6 by 5 is 1.2. 1.2 plus or minus 0.29, and if it is measured in centimeter, write this as centimeter, right? I hope you understood about how to calculate the uncertainties in case of a product. Okay, so in a product, what you can do is you can do something like this, arrive at a value of the net uncertainty, relative uncertainty, and after that you proceed. Okay, a simple product, we have something like this. But there are complex products also. Let us do 1 or 2 problems to get accustomed with that. Now, the next one. What we'll do is, we will use this one here. Y equal to a power n. So y is equal to a power n. You see delta y by y is equal to modulus of n delta a by a. What does it mean? It means whether n is positive or n is negative. Okay, even then this is always positive, because you know mistakes and errors cannot be negative. Today you go 5 minutes late to the class. Yesterday you went 5 minutes early to the class. Can you say that the mistakes of 5 minutes early and 5 minutes late, can you add up together plus 5 and minus 5 and make say and say that I am errorless? No, you cannot say that, right? So therefore you are always having an error. The reason is because you went 5 minutes earlier, that is also a mistake. You went 5 minutes late, that is also a mistake. So therefore there is a mistake being seen. Okay, so therefore mistakes cannot become negative, so you cannot add a negative with the positive values, right? So therefore now let us take for example y equal to a power n. Let me take let us say value of a is equal to 2 plus or minus 0.3 centimeter. 0.3 centimeter. I have something, let us say I am measuring, this is the length of the cube. This is the length of a cube. Now my question is, what will be the uncertainty in measuring the volume of the cube? Volume of the cube. Now, when I say uncertainty, which uncertainty you will ask? Okay, let me do one thing. I will say the uncertainty, which is nothing but your fractional uncertainty. I want fractional uncertainty. So how do you do it? Now, if at all, if something like this is given over here, you can just say, if suppose if it is given to you as v is equal to v0 plus or minus delta v, then your fractional uncertainty with here would be delta v by v. Very easy to do it. But how do we do it here? So what we need to do is, we need to take this information, we need to convert into this. How do you do it? Now, what is V0? V0 is the volume of the cube. If one length of this cube is given, what is the volume of the cube? Volume of the cube is nothing but a cube, right? Which should be 2 cube. Which is nothing but 2 cube. 2 cube, which is equal to 8 centimeter cube, which is already got. So therefore, I can now write V is equal to 8 centimeter cube. But I want delta V. How do I find delta V? Delta V, V is equal to a cube. Now by this formula, I can now write delta V by V is equal to 3 times delta A by A. Why? Because you see, because n is equal to 3, I can pull this down, right? And thus I can write like this. So which should be 3 times, what is delta A by A? This is 0.3 divided by 2, right? This is delta A, this is A here. So I will write this as 0.3 divided by 2, which should now be equal to 3 into 0.15, which is equal to 0.45, right? 0.45. Delta V by V is equal to so much. What is he asking? He has already asked me what is the uncertainty in measuring the volume of the cube, which is fractional uncertainty. We have got the answer here. You need not do this one also. But if he asks you about what is the absolute uncertainty, then what you need to do? You need to find delta V is equal to 0.45 times V, right? What is V? 8. Substitute that value. So you get 0.45 times 8. If I use my calculator, 0.45 star 8 will now be equal to 3.6. Thus, I will be writing this as equal to 3.6. And thus your V should be written as 8 centimeter cube plus or minus 3.6 centimeter cube. So thus, we will be able to address the uncertainty in finding the volume of an object. Okay. So given only the linear value. I hope this is clear. If not, then you can put your comments on your comment box. I'll be happy to explain you with some more examples. Okay. Next, we have seen how do you do this. We have seen multiplication. We have seen division also. Now division. Let us say, for example, you have A is equal to 3 plus or minus 0.2 centimeter and B is equal to 4 plus or minus 0.1 centimeter. And I'm asking you to find out the fractional uncertainty in for a value. So let us say I define a value y is equal to 3a divided by 2b. Okay, I'm asking you to find out what will be the fractional uncertainty delta y by y in this case. The first thing what you need to do, so 3 by 2, first substitute the value of a here. So sorry, this is not required. So now when you have something like this, what do we have here? See, delta y by y is equal to delta a by a plus delta b by b, right? What happens to this value of 3 and 2? Ignored, because these are all constants, okay? So it does not change. So you should not use this. Just take the variables over here. And now what you do is, what is delta a? Delta a is 0.2. What is delta b? As I delta by a, 3 plus or minus, so not plus or plus over here as 0.1 divided by 4. 0.1 divided by 4. Get me this value here. What is the answer here? 0.2 divided by 3 is 0.16 plus this is nothing but 0.2, 0.025, 0.025 here. This will also be 0.016 over here. So what will be the answer here? Let me do this. 16 plus 25 is 41. So this should be 0.041. This will be your delta y by y. And if I want percentage uncertainty, it will be 4.1%. I hope this is clear, right? So with this, we come to an end to understanding the uncertainties in calculations, okay, which is very, very important. In the next video, in the third part of this video, we will be starting with the significant figures. Okay, thank you.